Welcome back, everybody, to our next presentation. I'm really happy to welcome next to me Erik Hagen from WEIMA. He will talk a little bit about a case study of them and tell us a little bit about their shredding technology and how they can turn waste material into new composite products, which of course will be one of the steps to a circular economy. Erik, over to you. I don't want to talk too much. It's your presentation. You know most about it. Please tell us all about it.
Thank you very much, Mr. Bott, for the short introduction. Dear ladies and gents, welcome to my short presentation about the topic shredding technology, converting waste material into composite products, which is a WEIMA turnkey solution and which was installed and built in Europe. I would like to start first with a small introduction of myself, then going over to the company WEIMA, and then starting to present the project in details, step by step from the beginning to the end. And then I would be very happy after the last slide, if you have any questions, to ask whatever you require about the line. So, as Mr. Bott already told a little bit, my name is Erik Hagen. I'm the sales director for the company WEIMA. I've been working for over 20 years in the recycling business. I've been working now for 17 years at the company WEIMA, and I'm directly responsible for the sales in France, in the northern part of Europe, in Finland, in East Europe, as well in Asia and in Oceania, which is New Zealand, Australia and around. And yes, I'm as well responsible for all divisions at WEIMA, which I'm going to explain you later on. WEIMA itself is a company which has been founded in 1980 by Mr. Peter Ressler. That means it's already having a 40 years tradition. We are having so far a turnover, annual turnover of 50 million euro with around about 300 employees. And we have so far sold already over 35,000 installations worldwide and built each year around about 1,200 machines. That means that each month 100 machines are leaving the company, and this is mainly the single shaft shredders. We have 6 locations worldwide. The headquarters itself, where as well I'm located, is in Ilsfeld. This is a small town which is close to Stuttgart in the southwest of Germany. We do as well have there in Ilsfeld the production of the briquetting presses as well of the control cabinets of the machines. The main production anyhow is not in Stuttgart or Ilsfeld. This is in Annaburg, which is in East Germany. Further on, we do have as well a 100% daughter company in America, in Fort Mill, between North and South Carolina, where we do have the sales and service of the machines. Further, we do have a joint venture in China, in Yantai, where we have sales and service for mainly the wood machines and the small plastic machines. And then we have 2 service points, one in Poland, in Warsaw, and the other in India, which is in Gujarat. The divisions WEIMA is active in is mainly in shredding. As I mentioned already, we are producing mainly single shaft shredder. Beside that as well, we are producing 4 shaft shredders for different applications. We do as well granulators, mainly as a second step shredder after the pre-shredding. We do as well briquetting presses, and of course the very important division as well at WEIMA is the service. WEIMA is working mainly in the divisions you can see here on the slide. We sell a lot of machines in the wooden industry. That means for shredding of different kind of wood, like hardwood, softwood, for MDF, HDF, or chipboard, products like offcuts of furnitures or pallets or greenwood. Then we're as well very active, of course, in the plastic industry, where we make the biggest turnover. That is mainly for solid and rigid plastic, 3D plastic, like tanks, barrels, containers, as well as 2D plastic, film fibers, or as well textiles. Then we are active in the paper industry, where we are working in 2 different areas. For example, downsizing of office paper, as well of paper coming from the production plant directly, like pulp waste, rejects, or reggers. We do as well have the area metal, where we do the briquetting presses mainly, as well cutting of swerves, then going later on as a briquette to the smelter. Biomass, we are quite active. And last but not least, of course, in the waste industry, where we offer very often as well turnkey solutions, more or less the same as I'm going to present you right now. That's a bit a task. As I used to explain a little bit at the beginning, WEIMA was requested to find a turnkey solution to produce a kind of flake out of a blend of material coming from hard plastic, from soft plastic, as well as from wood, in a different blend out of different plastics without any pre-sorting, with contaminations coming from ferrous metal and from non-ferrous metal. And then to bring in this material and to downsize it later on as pure material to smaller 9 millimeter, to use it as WPC, means wood plastic composite, for a product. The task was further a productivity of up to 1.8 tons per hour, working in 3 shifts, so 24/7 around the clock, minus of course downtime for maintenance, and then installation in a temperature area where it's quite cold, minus 15 degree, and at the end, anyhow, up to plus 40 degree in summertime. So that was quite interesting target for WEIMA, and we found a very good solution for that, which I'm going to explain you later on. Here you can see some photos of the input product, HDP containers, HDE, PE, PPM pipes, PS material, barrels on the left-hand side, skeletons, PE bottles, as well as LLDP, LDP, and HDP and PP film, wooden pallets, wooden beams, wooden offcuts, or other small wooden furniture, which should be directly introduced into the single shaft shredder. The flow sheet at the end, which you can see here on that slide, was then by starting with a single shaft shredder from the series WKS. Production in average, as I said, 1.5 ton per hour, to downsize already to smaller 60 millimeter to have the best sorting result. Then the overbelt magnet, then the neodymium magnet, then later on the eddy current, so sorting out the ferrous metal, then the stainless steel, and at the end the non-ferrous metal, and then like a clean product going into a granulator, which is a fast rotating machine. That's as well why the machine wouldn't be too happy with foreign objects inside. And at the end, having a decent blend of material of around about 1 ton per hour to smaller 9 millimeter, to use that later on for the product. Here you can see the project drawing illustrated in a 3D shape. You can see here on the left-hand side the infeed belt in blue. So all material is put on the infeed belt, then directly introduced in the shredder, discharged by another belt where the overbelt magnet is placed, At the top end of the belt, it is the magnet drum, the neodymium drum installed. Then going to a cross belt with a speed belt into the eddy current, sorting out the non-ferrous metal. Then discharge into the granulator, and later on the air extraction into a double big bag system with a cycling on the top and air filter system. Of course, the core and the most important part of the line, as well you can say the bottleneck of the line, if this is not working fine, the complete line is working, is the single shaft shredder. We decided to go with a machine which has a high torque drive. Why? Because this drive can work under each condition, in winter and summertime, 24/7 without any downtime. And for this drive, you don't need any gearbox to generate a torque. And you don't need, let's say, any air cooling system, as you can directly cool down the drive with a water cooling system, which is as well very important to have a 24/7 hour operation. Why no gearbox? What was the idea for that? A gearbox is always a little bit hard if it comes to difficult applications with foreign objects inside, as the gears might wear out quite fast, and then the oil might leak, gearbox is destroyed, and it has to be replaced later on. That's something which we, of course, we wanted to prevent. That's why we were considering to have high torque drive at the end. The machine is working like that. You can see it a little bit on the arrows. Input comes from the top. You have a free-flying wing ram, which is then pushing the material against the rotor. The rotor is turning. The cutters installed on the rotor knife are then cutting the material. In front, you can see the last arrow on the right-hand side, which is then releasing the material through the screen to a transport belt and then going into the next step. The machine is having 500mm rotor diameter. It's available in 3 different sizes: 1.4, 1.8, and 2.2 meter. We decide for 1.8 meter machine. And the machine frame itself has a 40mm frame. So it's a heavy duty application. Here you can see a glance of the high torque drive. We are working here together with the company Baumüller. As I said, the torque drive itself can already generate a very high torque without having a gearbox in between. The motor is a synchronous motor, which is water cooled, and the drive speed can be adjusted by a frequency converter between 5 and 170 RPM. Further on, we are having a sliding clutch installed on the top pulley in order to protect the engine against any damage. What is as well quite important for the machine, as well for the product, is that you have a wing ram inside, which is free-flying wing ram. So it's not a segmented wing ram, which is, let's say, like sticking on the floor. It has a gap between the floor and the wing ram, as well between the sidewalls and the wing ram. This is, of course, limiting the wear dramatically. Further on, as you can see on the left-hand side, and on the photo right-hand side down, we are having an inspection flap, which is easy to be opened outside by an electro-hydraulic control system, which allows the operator to have a very fast and easy access to the grinding room in order to turn the rotor knives, in order to adjust and to turn as well the counter knives, and as well in order to sort out any foreign objects which might be unshreddable. The rotor which we put into that line is a V-shaped rotor. This is a universal rotor. We have beside a V-shaped rotor as well a F rotor and as well a body-coated rotor. This rotor has the big advantage that the knives and as well the knife holders are protected in a V-valley of the rotor itself. That means that the knives can cope with any impact coming from a foreign object. Further on, the rotor can work with different knives. You can see here some ideas which knives can be installed. It can be like a flat knife, it can be a concave knife, it can be a knife with additional cutting grooves, it can be a knife with tungsten carbide tips on it, it can be different shape like squared or like octagonal knife, it can be 40 to 40 millimeters, 60 to 60, 80 to 80 millimeter, always depending on the application. We were choosing a concave knife with dimension 60 to 60, which in our eyes was the best solution for this application. The machine then, of course, is defining the flake size by the screen. It has a screen installed with 60 millimeter. The screen itself is segmented. It's hinged inside and only fixed with 2 screws. That means it can be easily replaced within half an hour. The screen itself as well has a thickness of 15 millimeter and is done out of hardox. So the lifetime of the screen, even with very abrasive material, is guaranteed. The next step after the shredder, as I mentioned before, is the ferrous metal separation system, where we have simply an overbelt magnet, which is a permanent magnet installed over the discharge belt, which takes out all the ferrous metal. Then the stainless steel, which takes out the neodymium magnet, which takes out the stainless steel of the process. Then the last item to sort out the non-wanted materials is the eddy current. This is then at the end sorting out the non-ferrous metal. You can see a small idea what is a non-ferrous metal on the right hand side, like brass, like copper, aluminium, plumb bump, etc. Then, as mentioned before, it comes to the cutting mill, to the granulator. We were choosing here a WSM machine with a rotor diameter of 600 millimeter and a rotor length of 1000 millimeter, which is electromechanically driven. The machine itself has a RPM of 485 and has a V-shaped cutting blades where the material is always orientated to go into the center and not outside to the bearings, which might be harmful to the bearings. So they are well protected against any dust coming from the grinding room. The rotor is executed with 7 blades and with 3 stator blades in order to guarantee at least a capacity of 1.2 ton in a blend of material. Of course, the rotor knife can be adjusted outside of the machine by a special jig. The screen perforation is 9 millimeter, as discussed before. It's easy to replaceable without any additional tools. It's just to be lifted down to take off. So it's a very maintenance-friendly machine. So at the end, we do have a nice line turnkey installed from a blend of material out of rigid plastic, 2D plastic, wood, downsized to 9 millimeter, metal free, non-ferrous metal free, and then to produce a nice WPC product, as you can see here as an example, like a WPC pallet, for example. Other projects which are realized with exactly the same installation and as a turnkey are, for example, the processing of old mattresses to create insulation material as well with a size of 9 millimeter. Further on as well, textiles, which can be processed as well to insulation boards by using a 9 millimeter flake. installations which are a bit similar to the one at the moment explained are, for example, here an installation in Mexico with recycling line for plastic film, where you can as well see very nicely the input by a belt. Here as well you have a metal detection tunnel installed. Then our single shaft shredder WKS series discharge with an overbelt magnet, and it goes directly into an extrusion line from the company WEIMA in this case. Here the same WKS built with hydraulic drive, shredding of the jeans and of textiles, as I mentioned before in the other project. Here another installation of a WKS with a hydraulic drive, with an application for shredding paper rejects and as well paper wraggers. Here one in the States for in-house recycling of plastic film, as well with a single shaft shredder, in-feed by a belt, out-feed by a belt, separation by an overbelt magnet, and then going into the granulator. Then last one for the in-house is the car upholstery, as well in-feed belt, single shaft discharge into extrusion, and then at the end the biggest machine we can offer, a 3-meter machine in a super jumper execution with a rotor of 600 millimeter of shredding pipes with a diameter of 2.5 meter, going later on as well into the granulator and then into extrusion to produce a decent pallet, let's say, to mix it under the virgin material to produce new pipes out of that. If you're interested in more details about WEIMA, feel free to follow us either on Facebook, on LinkedIn, or on YouTube, where you can find very informative information, and where as well you can send any requests or questions at any time. Then I would like to thank you for your attention, and yeah, feel free to send any questions over you would like to ask me. Thank you.
Well, Mr. Hagen, thank you so much for that presentation.
Welcome.
Thank you for the nice examples you've given us. The questions are already coming in, so I think we've got a few minutes to answer them. Still, you've been talking in the beginning a lot about the WKS shredder you are offering, especially in that case with the high torque drive. And there came a few questions regarding this one. So could you tell us again maybe what is the maximum RPM and maximum torque you can produce with that?
Yes, correct. The RPM can be adjusted by the frequency converter between 5 and 170 RPM. And the torque we can generate on the system is up to 30,000 Newton meter.
Perfect. Okay, and in another installation where maybe 24/7 is not required, or the temperature is not that harsh, you could operate with a gearbox and get even higher results.
Yeah, let's say I wouldn't say you get higher results with a gearbox, but I mean, of course, the big goal of a gearbox is that the machine at the end is cheaper. Of course, the high torque drive costs a little bit of money. This is clear. But let's say for easy applications where you don't have, as I said, very harsh materials to shred, or where you don't expect any foreign objects inside, or very small quantity of contamination, there, of course, you can as well go with a gearbox. I mean, WEIMA, of course, is producing its own gearboxes. We have as well gearboxes up to a power install of 200 kilowatt, which, of course, are as well very robust, but not always recommended for all applications.
Sure, of course. And another question came regarding the throughput. You've shown us a few other examples in the end now, which of course can regulate that on the size alone. But what are the possibilities here regarding the throughput?
You mean on the installations I showed you at the end?
Yeah, and on the first one you presented a little more clearly, and yeah, how high can we go on the throughput with your shredders, and yeah, what are the different possibilities you got?
Let's say it's always depending on the material and machine size. This is clear. I mean, the biggest capacity we can do on pre-shredding is up to 40 tons per hour. That's mainly on municipal solid waste in the waste industry with the pre-cut 3000. And I would say on the fine shredder, where we can use a fine cut 3000, there we can go with municipal solid waste down to 40 millimeter in a throughput of up to 25 tons per hour. If you talk about rigid plastic, the one I presented you, for example, the pipes with the company Pipeline from Norway, with these huge pipes there, we can generate a capacity up to 10 tons per hour on HDPE plastic.
Perfect. Thank you for that. All right. Yeah, with that we can of course get a little lower, but it's still a lot, I believe. As far as I can tell from what I heard the last days, I would say that's a good throughput. Yeah. To all of the others of you, if you have any further questions, please tell them to us, and we will go through them as well. Another thing I would be interested in is maybe your view, Mr. Hagen, on how you would say, especially the idea of shredding different materials together is for the future, because from a lot of other speakers I heard a lot about you have to sort materials to get a very clear product at the end. Now you are here with another solution. Can you explain a little bit about that? Why do you think that makes sense, or how that will develop in the future?
Clear. I mean, you cannot always sort out each material in an easy way. So sorting is always very expensive, and of course depends on where it's installed. I mean, if you talk about Asia, where you have maybe as well low labor costs, it might be not that difficult. But I mean, my application was in the northern countries of Europe, where the labor cost is already quite decent high, I would say. And of course, there you would like to prevent the pre-sorting, either manual or automatically, doesn't matter. And of course, the less you sort, the cheaper at the end is the complete line. And then if you can make a good product out of that, which is not only RDF for burning, but really a product like these pallets or other product, which you can sell on the market for a good price. I mean, this is for sure the goal at the end.
Totally. And as far as I believe, the recycling we do now is better than the recycling we do in the future. So, and to do recycling now, it has to be economically sound. And if that's it, perfect. Yeah, thank you.
Thank you.
All right. I've got no more questions coming in from the chat right now. Mr. Hagen, thank you so much for being here. Thank you all for attending. I can only advise you to head over to the booth of WEIMA, where I'm sure you will find the contact data to get in contact with Mr. Hagen and his team. If you have any further questions, if you might be interested, head over there, get your information, get in contact. Mr. Hagen, thanks to you for participating here, for giving this presentation. The last words are, of course, yours.
Oh, I mean, no worries. Thank you very much as well, Mr. Put, for giving me the chance to present our company and our products. And yeah, I would be happy to have a chance again to maybe present next time another project with you together.
Sure.
Thank you.
Have a nice evening to everybody.
All the best to you.
All the best to you as well. Bye-bye.
Thank you. Bye-bye.